So nomenclature. You studied nomenclature in general chemistry. How many people liked nomenclature? How many people did not like nomenclature in general chemistry? Okay, and then about half the group has no opinion. That's fine. I find that organic chemistry nomenclature is more straightforward than the inorganic because you're following more the same rules for everything. And so there's not as many exceptions or different sets of rules to remember. So nomenclature is an important part of this course. And as we go on, we're just going to be adding to what we've already learned. So it's really important to stay up with it and not fall behind, because the farther behind you get, the harder it's going to be to catch up, and it kind of snowballs on you. So in the early days of organic chemistry, people just named stuff. They discovered or isolated a new compound and they gave it a name. Many of the names were related either to its function or where it came from. And so limonene comes from lemons, alpha-pinene comes from pine trees, and they all had these just kind of random names. We still use a lot of these common names. They're called common names or trivial names, but we need to have a systematic method for naming compounds that's related to their structure, because some people call it methanol, and some people call it wood alcohol, and some people call it methyl alcohol, and we have all these different names for the same compound. It gets very confusing. So IUPAC, the International Union of Pure and Applied Chemistry, is an international group of scientists. And they got together and they came up with a system for naming organic compounds. We're going to learn the IUPAC system, but we're also going to learn some of the commonly used common names. That's why they're called common names, because they're common. So for alkanes, like some of the other nomenclature systems, this makes a lot of use of prefixes and suffixes. And so this suffix or ending ane is used for all saturated hydrocarbons. So if you see a name that ends in ane, cyclohexane, propane, decane, you know it's a saturated hydrocarbon. The normal ones, normal alkanes, and again, normal means unbranched, those are named according to the number of carbon atoms. And that's from that table 2.1, which is also in your book. There's just the 4 strange ones at the beginning. So if we go number of carbons, 1, 2, 3, 4. 1 carbon is methane, 2 is ethane, and these you just have to memorize. Propane and butane. So methane is going to be CH4, ethane is going to be C2, and then to get the number of H's, we take 2N, here N is 2. 2 times 2 plus 2 is going to be 6. Propane is C3. 3 times 2 is 6, plus 2 is 8. And butane is C4. 4 times 2 is 8, plus 2 is 10. So how do you remember these guys? Well, to this day, I use a mnemonic that I think I learned either in high school or college, I don't even remember, using the first letters. And the sillier a mnemonic is, the better you remember it. Mom eats pickled bananas. I've actually never heard of a pickled banana. Can you pickle a banana? I don't know if you can. But Mom eats them. Mom eats pickled bananas. Makes me think she must be pregnant. So, methane, ethane, propane, butane. That's how I remember the order. This might work for you. If it doesn't, figure something else out. The rest of them go with those normal numerical prefixes. Pentane, penta is a prefix meaning 5. So pentane has 5 carbons. Those are the normal alkanes, the unbranched ones. If we have branches in our carbon chains, then we use as the root name the longest continuous carbon chain. And this can get a little tricky sometimes, and so you have to be a little creative. So we need an example for the longest carbon chain. I was having trouble with my PowerPoint images earlier, so I didn't get as many examples in here as I wanted. So I'm going to leave all those hydrogens off because they're pesky. I'll just draw the little bonds there so we can remember that there's hydrogens there. Now, oftentimes, the longest carbon chain is drawn horizontally, but not always. So if I just go across this way, I meant to draw that, 1, 2, 3, 4, I end up with 4 carbons. But that's not the longest continuous chain. 1, 2, 3, 4, 5. That's actually the longest chain. And you can try some other ones to see what happens. 1, 2, 3, 4. So sometimes you have to go around, and it's almost like one of those maze problems or something. And I'm trying to find the longest string of carbon atoms that are attached to each other in a row. I think of these carbon chains as being a little like a charm bracelet, with each of these being a link in the chain. And if the charm bracelet is laid down kind of messy, you can find the longest chain by just picking up each end, right? All of these single bonds have rotation, and so this molecule can actually move. If we drew it a little differently, we would have 1, 2, 3, 4, 5 carbons, and then this carbon is attached to this one that's smack dab in the middle. Do you see that those are the same thing? So we often have things attached to that carbon chain. We look for that longest carbon chain, and that's the base name or the root name, and then we look to see what charms are hanging on the bracelet, what's attached to the chain. And those groups that are attached are called substituents, and there's many different kinds of substituents. Alkyl groups are one kind of substituent. They contain only carbon and hydrogen. They come from alkanes. So if we look at methane, methane is one carbon and it has 4 hydrogens attached to it. Methane can't hook on to anything else because the carbon has 4 bonds. But if we erase one of these hydrogens, this becomes a methyl group. So we take the name methane and we change the ending, or take the ane ending off and add -il. And so that is methyl. That's a methyl group, and that can be attached to something else. So when we did that last example, we had 5 carbons in a row, and there was a carbon hanging down here. This carbon is a methyl group, because it's got hydrogens here. It's a CH3, and it's attached to something else. So any alkane, you can pull one hydrogen off of it and take that bond that you just broke and attach it to another carbon on a compound and make it into an alkyl group. So you just take the alkane name and you change the ending to -il. Let's just look at one more example for that. Let's look at ethyl. So ethyl has how many carbons? 2. So there's 2 carbons and then hydrogens all around. So that's ethane. And then to make that into ethyl, I'm going to remove a hydrogen, and I'm going to take off the ane ending. And this is now ethyl. And that can be attached to something at this point. Any questions? So we have these substituents attached to the chain. We need to know where they are attached. So we number the chain. And you have to start at one end or the other. So you've got 2 possibilities when you're numbering your chain. And the way you choose, because what's important to recognize is there is one best name for every compound. And the rules are set up so that we should all come up with exactly the same name. Now you can draw them many different ways, but the name is the same. The name is what identifies the compound. So how do we decide how to number? We number so that the substituents get the lowest possible numbers. So let's look at an example. Let's say we had 4 carbons here, and we have a methyl group here. So we can number it going this way, 1, 2, 3, 4, or we can number it from the other direction, 1, 2, 3, 4. There's a lot of counting in organic chemistry. Usually we don't count more than to about 10. There's almost no math though, so that's good, just some counting. A lot of students appreciate that. So if I use the red numbers, this methyl group is on carbon 3. And if I use the green numbers, it's on carbon 2. So I'm going to choose the green numbers because I want this to have the lowest number. So there's one correct way. If you did it with the red numbers, I would understand, another chemist would understand what you meant. They could draw it, but they'd say, yeah, but you named it wrong. When my second son was, he's probably about 3, we were at a restaurant, and he kept pointing over to the cash register and saying, dollar biller, dollar biller. And we figured out what he meant. He meant the cash register, which is where they put the dollar bills, but he called it a dollar biller. So, you name these wrong, and you're going to sound like the chemistry equivalent of a 3-year-old. We'll understand what you mean, but let's try to use the correct words. So every substituent is going to have a number, and we're going to indicate where it's attached in that way. And so to name this guy, what's the longest carbon chain? There's 4 carbons, right? What's the name of that? Mom eats pickled bananas, butane. So that's butane. And this is butane right here, and it's got a methyl group on it. The methyl group is on the second carbon. So we call that 2-methyl butane. And just to point out, if I numbered it this way, I'd still end up with 4. I wouldn't want to take this as the longest chain because that's only 3 carbons. Any questions? If we have identical substituents, like if you have 2 methyl groups or 4 ethyl groups or something like that, we use prefixes di, tri, tetra, etc. to indicate how many of them there are. But even when we use those prefixes, we still have to give a number to each of them. And we'll do some more examples. The substituents are listed alphabetically. When we list them alphabetically, we don't consider any of the prefixes in the alphabetization. That's a really long word to say. When we alphabetize, we don't consider the prefixes. So let's say you had diethyl. No, that's not a good example. You had dimethyl and triethyl. Because your particular compound here had 2 methyl groups on it and 3 ethyl groups. We're going to list the substituents in alphabetical order because we all want to come up with exactly the same name. Okay, that's the goal. So we alphabetize. Well, this is a prefix, di. So we don't consider the prefixes. We're not going to put dimethyl before triethyl. We're going to look at the actual substituent name, methyl and ethyl. So ethyl comes first. So we're going to do a lot of counting and we're going to do some alphabetizing. So brush up on your alphabet. E comes before M. When we write these names for the alkanes, it's going to be one word. There may be lots of numbers and prefixes and things, but it's all strung together as one word, no spaces. When we have numbers next to each other, we separate those with commas, and we separate the numbers from letters using hyphens. And so let's just do an example. Maybe this is, this could be 4, 5, diethyl. Oh, you're taken from up here. I'm making up another example. Sorry. So this would be 4,5-diethyl. There's the number 4 for one of those ethyls and the number 5 for the other one. And then maybe we've got 6, 7 trimethyl decane. Organic chemistry examples are a lot harder to make up on the fly than general chemistry because you can make up names that are actually incorrect. So I'm trying to be careful. And then I'll give you a preview. We also need to be able to take a name like this and write a formula for it. So these names, when we name them, we build up from the end. Decane. This is the root name. That describes how many carbons in the chain. So decane has how many carbons? 10. So this is going to have 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when you're drawing the structure, you can decide which end you want to start numbering on. I usually do the left side just because that's how we read. So I'm going to call this carbon number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the backbone of this molecule. And then the stuff at the beginning tells us the substituents that are attached to it and where. 4, 5, diethyl. Di means there's 2 ethyl groups. They are attached to the 4 carbon and the 5 carbon. So an ethyl group, let's see, make this green again. So on the 4 carbon, you're going to have an ethyl group. That's going to be CH3. Because CH2. Let's save that for later. Or as my older sons would say, let's shave that for later. I must ask you a question. Shave it for later. So that would be an ethyl group. There are hydrogens filling in the valences for all those carbons. I'm just not drawing them because it gets very cluttered. There's another ethyl group on the 5 carbon. I can draw it down here, or I can draw it up there. That's what makes grading assignments like this so challenging, is because you could end up with 20 different drawings, and yet they could all be correct. 6, 6, 7 trimethyl. That means on the 6 carbon, there's a methyl group, and on the 6 carbon, there's a methyl group, and on the 7 carbon, there's a methyl group. And you may say, well, that's kind of redundant. Well, these are some really intelligent people, and they argued a long time about how to do this, and it works, and so we're just going to go with it. So here we've got a methyl group and a second methyl group, and then on the 7 carbon, we've got another methyl group. Now that's kind of messy, isn't it? There's no real work to show when you do problems like this, naming things or writing formulas, but you'll write some stuff down and then you kind of have to copy it over again and make it pretty so that somebody else can see what you were scribbling about. So now I've got the carbons all laid out, how they're attached and everything, but then to show that as an answer, I would want to recopy it and put all the hydrogens in. But what I was really getting at here was the numbers are separated by commas. The number between a letter and a number, there will be a hyphen. So there's another letter to number. And this one, methyl, is just sandwiched right onto the decane. There's no spaces anywhere. Any questions? Mm-hmm.
How do you know which number from right to left or left to right?
We number so that we get the lowest numbers. So let's just look at what would happen if we numbered it a different way. What if we numbered from the other end? I'll do purple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, those 2 ethyl groups, this one is on the 7 carbon and on the 6 carbon. Okay, see, this is an example. 6 and 7. And the methyl groups would be on the 4, and 2 on the 5. So that would be 5, 5, 4, 5, 5. 4, 5, 5 instead of that. Which is a better numbering? Which gives lower numbers overall? It's kind of close, isn't it? They both have a 6, but this one has 2 6s. They both have a 7. They both have a 4. This one's got 2 5s. This one has 1 5. So this one has 2 5s compared to the blue one having 2 6s. So actually, there's an example of me making up a name that is not correct. So this is actually, in the purple, 6,7-diethyl 4,5,5 trimethyl decane is the true name. The blue name is numbered wrong, which is really easy to do when you make up names in your head.
How did you get the 10 carbons straight from?
I got the 10 carbons from this name at the end, decane.
Okay,
Yeah. So this little prefix here before the ane tells me how many carbons. There's a lot of little pieces put together here. It's like learning a new game. At first, it doesn't make a lot of sense, and you play the game and people say, oh, no, you can't do that. Oh, you have to do this. And after a while, you learn the game, and then it becomes a little more fun. Now, this may never be fun for you, but if you can manage to get yourself here from home, you can learn how to do this. Especially if you can actually get home again afterwards. Right? It's little things that you have to put together in the right way, but it's not calculus, or it's not even molecular orbital theory or talking about the strange nature of electrons. So it's just learning a system of rules, and it's going to take some practice. So let's name these guys. So the first thing we want, oops, we don't want to do that. The first thing we want to do is find the longest chain. So we're going to look at this guy, and if we go this way, 1, 2, 3, 4, 5, 6, we get 6 carbons. But we have possibilities. We could come up and around this way. See, 1, 2, 3, 4, 5, 6, 7. But if we went 1, 2, 3, 4, 5, 6, 7, 8, we actually find that there's 8 that way. Let's try this. So here is our longest chain. I'm just highlighting it. That's our longest chain, and that tells us the root name of the compound. 8 carbons would be what? Octane. And so you write that over to the right, and you leave some space in front. So even when you're writing the name down, it kind of ends up messy sometimes because you don't leave enough space. So that's octane, and then we're going to look at what is attached to the octane. What's not included in those, good grief, I'll give up on that. We've got this guy over here and this guy over there, right? Those aren't part of the chain. These are alkyl groups. And so we look at how many carbons in that alkyl group. This one right here has 1 carbon. There's another one over here, it's got 1 carbon, right? So 1 carbon is methane, and we change the ending to methyl. So on this octane, we have methyl. And how many methyls are there? There are 2, so it's dimethyl. And then we have to decide how we're going to number it. In this instance, it doesn't make a difference, and sometimes it doesn't. If we start at this end, we end up with that one being on 3. If we start at the other end, it's also on 3, 4, 5, 6, 7, 8. We'll end up with the same numbers either way. So this methyl is on the 3rd carbon, and this one is on the 6th. And so we'll list those in numerical order, and this will be 3, 6, dimethyl octane. Any questions?
So you don't know the alkane ones? The alkane groups?
Well, these are considered substituents. They're attached to the main chain. And so we just indicate them by what carbon on the main chain they are attached to, but they don't have numbers themselves.
Okay.
And the name, this name octane, is based on the number of carbons in a continuous chain, not on the total number of carbons in the compound. Because this actually has 10 carbons in it, but it's got branches in it. There's a little tiny branch here, and there's a little branch there. Any other questions? Let's do this guy over here. What's the longest chain?
All the way through to 8.
Yeah, 1, 2, 3, 4, 5, 6, 7, 8. So that's another octane. So I'll write octane over on the right side and leave room in front for stuff. So here's our longest chain. And if it helps you when you're doing this to use colored pencils or highlighters or something, go right ahead. Anything to help you see what's going on. And then let's look and see, well, what are the substituents on here? What's not on that main chain? I've got these guys that are all hanging on, right? In this example, these are all the same, aren't they? It's our same friend as over here. Those are methyl groups. So methyl octane, how many methyl groups? 4, and the prefix for 4 is tetra. So tetramethyl octane. And then we have to decide how to number. And you can start at one end or you can start at the other end. 1, 2, 3, 4, 5. So that's going to give me, I'll write it up here, 3, 4, 4, and 5. And if I number from the other direction, 1, 2, 3, 4, 5, 6, I'm going to get 4, 5, 5, 6. Any questions about just how I got those? So it's kind of a trial and error thing. You do it one way, you see what you get. You do it the other way, you see what you get, and you ask yourself, well, which one has the lowest numbers? Well, these numbers are lower. And so I want to use this red numbering instead of the purple. And so then in front of all this, I'm going to have 3, 4, 4, 5, dash. 3, 4, 4, 5, tetramethyl octane is the name of that compound. Any questions?
So you only count the ones that are outside of the chain? Or the methyl?
Yeah, the chain, the highlighted section here, gets included in the name octane. And so then we have to account for everything that's not part of that chain. And we ignore the hydrogens. We know that there's just enough hydrogens, so we don't have to deal with those. But we're going to look for carbons that are not part of that chain, and then we're going to have to say what they are and where they are. Any other questions?
So to figure out which number are lower, do you add them all together to see what the...
There are situations where you can just look at the total of the numbers and say, well, 3 and 4 and 4 and 8 and 8, 16, this would be 16 and this would be 20 and 18 is lower. But then it gets a little bit more complicated than that.
Okay.
Yeah. So that's why we don't teach you to do that, but at this point you can. But we're going for lowest numbers. So I already kind of did this one. The ethyl group is ethane. CH3 is ethane, and we're going to take off a hydrogen. We're going to take off a hydrogen, it's going to be CH3CH2, and then it's going to attach to a chain, and that would be an ethyl group. So the ones we named in the previous slide, the only groups were methyl groups, but we could also have ethyl groups. And then when the alkyl groups get a little bigger, they get a little more complicated. So let's look at propyl. Propyl has how many carbons? Mom eats pickles, pickled bananas, right? That's the third one, so 3 carbons. So this is propane. And what's called a propyl group is when you take a hydrogen off of the end. So if I remove that one, this is a propyl group. But what if instead of removing this hydrogen, I took the one off the middle? Would it be different? Yeah, it would. Pesky hydrogens. Need like a rubber stamp kind of deal. Just stamp hydrogens all over the place. So if I remove this one, now this is getting attached to the parent chain by the middle carbon instead of the end carbon. And so this group needs a different name because it is different. And so this is called isopropyl. Iso is a prefix that sort of means the same. So this is, in a sense, the same as propyl, and yet it's not quite the same. We didn't have this problem with ethane because ethane only had 2 carbons. And so it didn't matter which hydrogen you took off. If you take this one off, or you take this one or this one, you're always taking it off one of the carbons on the end because they're both on the end. But with propyl, you've got 2 end carbons and 1 in the middle. And then butyl, the butyl group, there's 4 variations. And both the 2 variations of propyl and these 4 variations of butyl are very commonly used, and so you need to memorize them. So this one is called butyl. That's the normal alkane butane. My pointer has developed a mind of its own. I'm not even touching the screen, you silly thing. Okay, thank you. So butane has 4 carbons. We take 1 off the end. That's considered the regular or the normal butyl group. Here we're taking 1 off that's second from the end. And so this is called secondary or sec-butyl. These are more common names, but we use them a lot. This could also be called 1-methylpropyl, but we just won't go there right now. And then we have, this is isobutane. This is taking butane and making it into a branched alkane instead of a straight chain. And on this branched butane, we can take 1 off of a methyl group. It could be this one, or that one, or this one. They're all equivalent. If we take 1 off the end, that's called isobutyl. And if we take the 1 off the middle, this is called tert-butyl for tertiary. And tertiary and secondary will make a little more sense later. But you need to know these guys. There's a fair amount of memorization that has to happen, and so you might want to make some flashcards. The website for the book has some flashcards that you can look at and quiz yourself online, and so that might be helpful as well. We can also have halogen substituents. The halogens are fluorine, chlorine, bromine, and iodine, and when they're named as a substituent, we just take the element name and get rid of the ene and put an O. So fluoro, chloro, bromo, and iodo. The IUPAC names list halogen as a substituent. So just a quick example of that. This is methane with a chlorine on it. And so the IUPAC name is chloromethane. But there's also a common name, which instead of looking at this as methane with a chlorine on it, looks at it as chlorine with a methyl group on it. And so the common name is methyl chloride. It's kind of a glass half empty, glass half full kind of thing. So IUPAC name, common name. We'll sometimes see the letter R in a structure, like RCl. R just means an alkyl group. It could be tertiary butyl, it could be ethyl, or decyl, or anything. It just means some alkyl group, just carbons and hydrogens with single bonds. So this is chloroalkane or an alkyl chloride, depending on IUPAC. So let's do this one real quick, and then we'll be done for today. This is a condensed structure, isn't it? And it can be a little hard to look at and to see what is going on. So let's turn that into a line structure so that we can see where the carbons are. So I'm going to just do these two carbons first, and this carbon is attached to another carbon, so I'll make an angle. So I've gotten to this guy, and then attached to this guy, there are two CH3 groups. So there's two. And this guy over here has three CH3 groups. 1, 2, 3. This is this carbon right here. Let's see. This carbon is right here. And so on the next carbon over is where that bromine is. So the bromine is right here. So what is our longest chain? Any of these that we start at, it'll end up being the same, right? So 1, 2, 3, 4, 5, or 5. No matter how we count, we end up with 5 carbons as the longest continuous chain. 5 would be what? Pentane? So we're going to call this our chain, our backbone, and then what's attached to that? That's a methyl group over here, and a methyl group, and a methyl group, and this is a bromo group. So we've got methyl and we have bromo. Which comes first in the alphabet? Bromo. So we're going to list bromo first, and then methyl. So it's going to be bromo, I'm leaving some space, and then methyl over here. How many methyl groups are there? 3. So it's going to be trimethyl. And should we number 1, 2, 3, or 1, 2, 3, 4? 1, 1, 2, 3, 4. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. It's going to be 3 bromo either way, isn't it? So it's going to be 3 bromo, so there's no difference there. If we do the red numbers, what do the methyls end up as? 2, 2, and 4. And if we do the purple numbering, we get 2 and 4, 4. So this one's better. So in here, we're going to have the 2, 2, 4. And then you have to recopy that. But it's 3 bromo, 2, 2, 4 trimethyl pentane. I'll see you on Thursday.